Welcome to section 6.6, factoring special binomials and then a factoring strategy. So we're first going to look at the difference of squares, and if you remember from our section on multiplication, when we were multiplying two conjugate binomials, we would get a squared minus b squared, and a squared minus b squared is the difference of squares. So how we're going to factor a difference of squares is we're essentially going to consider the square root of each term, and we're going to factor it using kind of opposites or conjugates. I'm going to call them opposite right this time, so opposite binomials. Okay, so let's look at 49x squared minus 81y squared. And let's go through our steps, right? Step one, do we have a greatest common factor? No. And we count the terms, and there's two terms. And for two terms, we see if it's a difference of squares. And it is a difference of squares. So if it's two terms, we ask ourselves, is it a difference of squares? And it is. All right, 49x squared, let me rewrite that. 49 is 7 squared, and x squared is x squared. So see how I wrote that in parentheses. And then 81y squared, 81 is 9 squared, and y squared is y squared. So I have our parentheses. And so inside the parentheses, we have our a and our b, just the a and the b. So a squared minus b squared, let me write that below. We have a squared minus b squared. And so we know that that's going to be a minus b, a plus b. Or a plus a minus b, something like that. So how this is going to factor our original one, in this case, our a is 7x, and our b is 9y. So this is our answer, 7x plus 9y times 7x minus 9y. And I'll put a box around that because that's your solution. That's how we factor that 49x squared minus 81y squared. Okay, and now let's consider this. What happens if instead of minus, we have a plus? So 49x squared plus 81y squared. So notice we have two terms, but it's on a difference of squares. It's a sum of squares. So note, this is a sum. And a sum of squares is actually prime. If we can't factor out a greatest common factor, we can't do anything. So this is prime. So let me just say, that's for this one right here. All right, so the sum of squares is prime. A squared plus b squared is prime. All right, so now we're moving on to our other two-term binomials. Remember, section 6.6 is factoring binomials. Our first example was two terms and difference of squares. We're also going to be looking at two terms with the difference of cubes. So cube is to the third power, and the sum of cubes. Okay, whoops. And we just have to memorize these next formulas. These are a little bit more involved, but they're very similar. So let me do the template. Okay, and then I'll do A in blue. And I'll do B in green. All right, and then this is the template. All right, so we have AB, A squared, AB, B squared, no matter if it's a sum or a difference. So how we remember what signs go in between, we use the acronym SOAP. S stands for same. O stands for opposite. And AP stands for always positive. All right, so, and we're referring to the sum or the difference. So if it's the sum, it's going to be plus, minus, always positive. If it's the difference, it's going to be minus, plus, always positive. So same, opposite, always positive. So let's fill those in. And then those are our formulas. And that's something that's going on a flashcard. That's something you guys are memorizing. All right, and then you guys can multiply this through to verify the formula. I wanted to make one more note. This resulting trinomial in both formulas is prime. So don't try to factor it. You cannot factor it anymore. All right, so A squared minus AB plus B squared, or A squared plus AB plus B squared, that trinomial is prime. All right, so let's look at an example, 27x cubed plus 8. So again, we go through our process. Is there a greatest common factor? No. We count the terms. We have two terms. So now if we have two terms, it's either a difference of squares or a sum or difference of cubes. And we have a sum or difference of cubes. So if it's helpful, you can rewrite this in terms of the cube. And that just helps us get your A and your B. So in this case, our A is the stuff we're cubing, so 3x, and the B is 2. All right, so let's work this out. So we know it's going to be A plus B, A minus AB, so I'll do the SOAP, and then always positive at the end. Same, opposite, always positive. Our A is 3x, so A goes there. There's going to be 3x squared, all squared, so use parentheses. And then our B in our formula goes something like this. All right, and then if we simplify everything, we get 3x plus 2. 3x all squared, that's one of our exponent rules, is 9x squared, minus 6x plus 4. All right, so 1, 2, 3, we're going to factor 3 more. Go ahead and push pause, and then come back and check your solutions. All right, let's see how you guys did. So the first one was the difference of two squares. So again, there's no greatest common factor. You counted the terms, and it's a difference of squares. And here's the squares. Remember, 1 is a square. 1 is just 1 squared, so it's a square. And then when you factored it using A plus B and A minus B, notice here we could keep going. 9x squared minus 1 is, again, difference of squares. So we could rewrite that as 3x plus 1 times 3x minus 1. So your whole solution is this 3-part binomial. So there's 9x squared plus 1. And then if we multiplied this back, we would get 9x squared minus 1. So there we go. Number 2 is relatively straightforward. No greatest common factor, 2 terms, difference of cubes. 64 is 4 cubed. So here we go here. Number 3 was a little bit different because we had to factor out a greatest common factor first. And remember to include that 2 in your final solution. All right. So carrying on, we have our strategy. So how to factor a polynomial. All right, so step 1, always check for the greatest common factor, which we've been doing this whole time. Don't forget to include the greatest common factor in your final product. And remember to factor out a negative sign. You want your leading coefficient to be positive. Your next step after the greatest common factor is to count the terms. So we just went over 2 terms. If it's a difference of squares, we're looking at a plus b, a minus b situation. So for instance, 64t squared minus 81a to the 4th. Your a is 8t, and your b is 9a squared. All right. Remember, a squared plus b squared is just equal to a squared plus b squared, and that's because it's prime. And then we have a difference of cubes when we have 2 terms in our polynomial. So remember SOAP, so same sign, opposite, always positive. And so for this example, 64t cubed minus 27, let's see, 4t is your a, 3 is your b, and then we square our a, multiply 4t times 3, and then square the 3. All right, and then a cubed plus b cubed, it's the same, but our signs change. So we use SOAP. So same sign, opposite, always positive. So for this one, notice our example, all I did was change the sign from minus to plus. So it's the same thing as before, we're just going to change the signs. And the last one is always positive. All right, so let's say we count the terms and we have 3 terms. So 3 terms, we have our AC method or trial and error. And we also have some shortcuts. For instance, this one, a squared plus 2ab plus b squared is a perfect squared trinomial, so it's a plus b all squared. And that's helpful for these examples, like 256x squared plus 416x plus 169. So 256 is 16x squared, or I'm going to say 16 squared. 169 is 13 squared. So we would want to check if the middle term, 416x, is 2 times 16x times 13. And it is. 2 times 16 times 13 is exactly 416. So we can write that this is a plus b squared. Okay, and if the middle term is negative, like in this next example, it's going to be a minus b squared. So the thing that would change in the bottom example, notice the C is positive, and now B is negative. Same numbers, but it'd be 16x minus 13 all squared. All right. And then another special case of our three terms is when the leading coefficient is 1. And remember, that's where we find two special numbers, P and Q, where P times Q equals C, and P plus Q equals the middle term. All right, so this next example, it's three terms. Our leading coefficient is 1. Everything is positive, so that kind of helps the situation. Makes it a little bit easier. So we know both our binomials are going to be positive. So now we have to find two numbers that multiply to 12 and add up to 13. And those magic numbers are 12 and 1. All right, and then finally we have ax squared plus bx plus c. You can always use your guess and check, trial and error. We saw that that can be a little bit problematic sometimes. But essentially what we're going to be doing is we're going to be finding two numbers and replacing the middle term with those two numbers. All right, and let's just do a little bit of side work over here. So remember the AC method, we multiply AC, and we find two numbers that multiply to AC and add up to B. Let's just call them V and W to try to make this into a formula. And we replace those two, or Vx plus Wx, we replace that with B. And then once we have a four-term polynomial, we factor by grouping. Okay, so in this example, 2a squared plus 5a minus 12, if we wanted to do the AC method, we might have to do a little scratch work down below. Let's see how much room we have. So we have to find two numbers. We'll do it off to the side. 2AC, 2 times negative 12 is negative 24. Let's make sure we get the negative sign in there. Middle term is plus 5, so positive 5. So two numbers that multiply to negative 24 and add up to positive 5 are 8 and negative 3. So we're going to replace 5a. Remember to write the negative 1 first, if there's one negative 1. 5a is going to be replaced with negative 3a plus 8a, because we didn't change anything. That's exactly what it is. All right, and then we have the 2a squared. We have the minus 12. And then we factor by grouping. So group them together. Factor out the greatest common factor in both. And then factor out, again, the greatest common factor. All right. And then finally, we've already talked about it, when we have four terms, when we count up our polynomial, there's four terms, we factor by grouping. Notice in this example, we actually have a greatest common factor of 2. So let's get that out of there first. And then we still have four terms. So then we factor by grouping. Notice in this case, when we go to group our two groups of 2, the second one starts with a negative, so we got to include that negative in the parentheses. Factor out your greatest common factor. The next one, the only common factor we have is a negative 1. So we're going to factor out a negative 1. We want that first term to be positive. All All right, and then again, we have the 5y minus 3 as a greatest common factor, so we're going to factor that out. Like that. And we're almost done. Remember, I remind you in that first step, don't forget the original greatest common factor you pulled out. So we would want to write that 2 in there. And that would be your final answer. And then finally, we can always check our work, and it's very important to check your work, especially on an exam or a homework quiz, by multiplying your factors to make sure you get back to your original polynomial.